Hello children, welcome to AIMS India's online classes. In today's video from physics subject, force and laws of motion topic we are going to discuss. So we have already discussed about inertia, force and motion relation, and about Newton's first law, about inertia of rest, motion, direction. About linear momentum we have discussed already, about Newton's second law, and about weight, and about impulse, Newton's third law. These topics we have completed. Limitations of Newton's laws of motion. So up to here we have completed. So the limitations of Newton's laws of motion are it is applicable for speeds very less than speed of light. If the speed of the body is very less than, this symbol stands for very less than speed of light, then these laws are applicable. And it is not applicable for in the domain of atoms, molecules, subatomic particles. We are all aware of that. Inside the molecules there will be atom, inside the atom there will be nucleus, inside the nucleus there will be proton and neutron, electron will be revolving around the nucleus. These are called subatomic particles that we have learnt already. But these Newton's laws of motion are not applicable to these molecules, atoms and subatomic particles. And it is not applicable when there exists a very strong gravitational field. If in a place the gravitational field in this area, if it is very high, there Newton's laws of motion are not applicable. So the concept of Newton's third law is not applicable when particles interact with each other by means of a force field. Newton's third law, if they suppose if two bodies are there, two objects are there, object 1 and object 2, if they are interact with each other with the help of force field like gravitational field, magnetic field, electrostatic field, in that case Newton's third law is not applicable. When they are in contact with each other, when the two objects are in contact with each other, then Newton's law will be applicable. In some cases, when there is, suppose here one magnet is there, here one iron rod is there. Between the magnet and the iron rod, though the iron rod is not in contact with magnet, but due to magnetic field, magnet can attract the iron. In such cases, Newton's third law is not applicable. And Newton's laws are not applicable for very small accelerations. If the acceleration is less than 10⁻⁻10 meter per second square, for that kind of accelerations, Newton's laws of motion are not applicable. So these are the limitations of Newton's laws of motion. Newton's laws of motion. So let's solve some examples here based on this Newton's laws of motion. Example 1. Calculate the force required to produce an acceleration of 5 meter per second square in a body of mass 2.4 kg. So we have to calculate the force F. F value we have to find to produce an acceleration of 5 meter per second square. Acceleration A value they have given in a body of mass 2.4 kg. Mass value M they have given, M given and A value they have given, we have to find F. We know that from Newton's second law, force is defined as force equal to mass into acceleration. Mass value 2.4 kg, acceleration value 5 meter per second square. Here kg and meter per second square, they are the standard SI units. no need to change them. 2.4 into 5, 5 4 times 20, 5 2 times 10 plus 2, 12. 12.0 will come. Here actually the unit is kg meter per second square, but we have a special name called Newton on behalf of, which is named on behalf of Sir Isaac Newton, instead of this kg meter per second square. So this kg meter per second square is called as Newton. So 12.0 newtons is the answer. Next, example 2. So a body of mass 2.5 kg, m value 2.5 kg, is moving with a velocity of 20 meter per second. Velocity, v value 20 meter per second. Calculates its momentum. Here momentum means, the formula of momentum is mass into velocity, because it's a product of mass and velocity. Momentum symbol is P. It's a product of mass and velocity, but mass is given as 2.5 kg, velocity given as 20 meter per second. Then what is the momentum? mv, that equal to 2.5 into 20, which is equal to 50 kg meter per second. 50 kg meter per second. So here kg per meter square is called as Newton, but not kg meter per second. Next, example 3. A force acts for 0.2 seconds. For how much time the force is acting means, it is acting only for very less time, which is 0.2 seconds. On a body of mass 2.5 kg, m value 2.5 kg, which is at rest. Means in the beginning it is at rest, means u value, initial velocity is 0. The force then ceases to act. After acting for 0.2 seconds, then the force ceases to act, and force stops to act, and the body moves through 4 meter in the next 1 second. In the next 1 second, after 0.2 seconds, next 1 seconds, the body will move 4 meter. Calculate the magnitude of force. So here, according to question, when the force ceases to act, when the force stops to act, the body will move with a constant velocity, which is 4 meter in 1 second. Actually, when the force ceases to act, the body will be moving with constant velocity, because it is moving a distance of 4 meter in 1 second. So its uniform velocity will be 4 meter per second. This is the uniform velocity of the body. But here initial velocity is 0. But final velocity after 0.2 seconds, it is moving with a uniform velocity of 4 meter per second. So why the velocity is uniform? Because force ceases to act. So that's why velocity is uniform, which is 4 meter per second square. We can take it as final velocity. So time interval 0.2 seconds. Time interval 0.2 seconds. So acceleration, so A equal to v minus v by t, 4 minus 0 by 0.2, which is equal to 20 meter per second square. 20 meter per second square. So then force equal to ma, formula ma, where mass is 2.5 kg, acceleration is 20, 2.5 into 20 is nothing but 50 newtons is the answer. 50 newtons is the answer. Next one, example 4. So a ball of mass 20 grams. So here gram is not a SI unit. We have to change it into kg. Is initially moving with a velocity of 100 meter per second. On applying a constant force on the ball for 0.5 seconds time, it acquires a velocity of 150 meter per second. Calculate the following. The ball mass is 20 gram, initially moving with a speed of 100 meter per second, but after applying force for 0.5 seconds time, its velocity will increase to 150 meter per second. Calculate the following. What we have to calculate? Initial momentum, final momentum, rate of change of momentum, acceleration, magnitude of force. These five questions we have to solve. First one. So here given mass equal to 20 grams, we have to convert into kgs. Grams can be converted into kgs by dividing with 1000. 20 by 1000 kgs. 0 gets cancelled. 2 by 100, which is equal to 0.02 kg. This is the mass. Initial velocity 100 meter per second. Time interval 0.5 seconds. Final velocity 150 meter per second. Initial momentum of the ball is, initial momentum means initial velocity into mass. Initial velocity into mass. So mass into initial velocity, where mass is m, initial velocity is u. So P equal to mu, where mass 0.02 kg, initial velocity 100 meter per second. So 0.02 into 100, which is equal to 2 kg meter per second. So this is the initial momentum of the ball. So final momentum means mass into final velocity 0.02 into 150, which is equal to 3 kg meter per second. That is P2. And they have asked rate of change of momentum. Rate of change of momentum is change of momentum with respect to time. Change of momentum is final momentum minus initial momentum by time. So here change of momentum delta P, time interval delta T. Change of momentum means here what is the momentum? Here 3, here 2. So 3 minus 2 by 0.5, 1 by 0.5, that equal to 2.0 kg meter per second. Kg meter per here kg meter per second square, children. Because momentum is kg meter per second, here kg meter per second by second, which is equal to kg meter per second square, and the special name for kg meter per second square is Newton. So 2 newtons is the answer, rate of change of momentum. Acceleration is v minus u by t, 150 minus 100 by 0.5, which is equal to 100 meter per second square. Force equal to mass into acceleration. So what is the force? Mass here 0.02. Acceleration in fourth question we have calculated 100. 0.02 into 100 equal to 2.0 newtons. Next one, example 5. A cricket ball of mass 200 grams. A cricket ball which is having a mass of 200 grams, moving with a speed of 40 meter per second, is brought to rest by a player in 0.04 seconds. Calculate the following. Actually, a ball is having mass 200 grams. It is moving with a speed of 40 meter per second. So, while catching it, it is coming to rest. It is brought to rest by a player. By catching it, he brought it to rest. That happened in 0.04 seconds time. Calculate the following. Change in momentum of the ball, average force applied by the player. These two we have to calculate. So mass given that 200 grams, we can convert into kgs by dividing by 1000. 2 zeros gets cancelled. 2 by 10 equal to 0.2 kg. That is mass. Initial velocity, they have given that 40 meter per second. Final velocity, finally it is brought to rest. So final velocity is 0. In how much time it brought to rest? In 0.04 seconds. That is the time. So these are the given values, children. So now we have to calculate initial momentum, P1. So mass into initial velocity. 0.2 into 40. Answer 8.0 kg meter per second. Final momentum. Mass into final velocity. Here final velocity is 0 because ball has been stopped. 0.2 into 0, which is equal to 0 kg meter per second. That is final momentum. Change in momentum means final momentum minus initial momentum. 0 minus 8.0, which is equal to minus 8.0 kg meter per second. This is the change in momentum. So, average force. How to calculate average force? We have a formula which is change in momentum by time. So, change in momentum, how much? Minus 8.0. Minus 0 means no need to keep it. Already we have calculated, which is minus 8.0. No need of minus 0 here. Minus 8.0 by 0.04. But here, point after one decimal is there. Here, point after two decimals are there. We can keep one more 0 here. If we remove the point, the numerator will become 800. The denominator will become 004, which is equal to 4. Because after decimal point, we have two places in the numerator part, two places in the denominator part. We can remove the decimal point and we can write like that. Here 004 means it don't have any value. That's why 4 we have written directly. Minus we have here. So which is minus 200 newtons. 4 200s are 800 minus 200 newtons. So the negative sign shows that force is applied in a direction opposite to the direction of motion of ball. Direction of motion of ball. So whenever there is minus sign, the force direction will be opposite to the motion of the ball. That we have to imagine. Next one, example 6. A motorcycle is moving with a velocity of 108 km per hour. It is not standard unit, children. We have to change into meter per second if there is any need. 108 km per hour. And it takes 5 seconds to stop it after the brakes are applied. Means after applying the brakes, the motorcycle will take 5 seconds time to stop it. Instantaneously it cannot stop. It will take some time, 5 seconds time to stop the motorcycle. So now calculate the force exerted by the brakes on the motorcycle if its mass along with the rider is 250 kg. 250 kg. So here, a motorcycle moving with a velocity of 108 km per hour, which will be the initial velocity of the motorcycle. 108 km per hour. So we can convert into standard unit by multiplying with 5 by 18. We can convert into meter per second. So 18 6 times 108, 6 5 times 30. 30 meter per second is the initial velocity. Final velocity means finally it has stopped. So final velocity will be 0. So time taken to stop how much? 5 seconds time. 5 seconds. So mass of motorcycle along with the rider 250 kg. 250 kg. Now change in velocity of the motorcycle is 0 minus 30 minus 30 meter per second. It happened in 5 seconds time interval. Therefore acceleration is change in velocity by time minus 30 by 5, which is equal to minus 6 meter per second square. So now, what is the force applied? For magnitude of force applied by the brakes. Force applied by the brake is equal to mass of the bike along with the person into acceleration. So mass of the person, mass of the motorcycle along with the person 250 kg into acceleration 6. If you multiply, 1500 kg meter per second square will come, which is equal to 1500 newtons, which is equal to 1500 newtons. Okay, children, that's all for today. That's all for today, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. So please visit our website, children, www.aimstoday.in, for information regarding previous online classes, quizzes, worksheets, activities, English tests, coding skills. Thank you, children. Have a good day.